7.6 Rotations and Rotational Symmetry. Your learning outcome for this lesson is to demonstrate an understanding of line and rotational symmetry. Okay, so to start off with, it says a shape has rotational symmetry when it can be turned less than 360 degrees about its center to match itself exactly. And the number of matches in a complete turn is the order of rotation. So let's take a look at this shape, which hopefully you're thinking to yourself is a hexagon because it's got 6 sides. And if I were to, let's say this was on a piece of paper and I were to stick a pencil right in the middle and start turning this either, by the way, you're going to need to know these words, and you already know this. This is clockwise, and turning like this is counterclockwise. So if I were to turn this shape either way, and let's say this was my starting point, I could turn this shape 1, 2, 3, 4, 5, 6 times before it ended up exactly on itself. So if I started here and I turned it 1 turn, this would end up there. If I turned it 2 turns, this would end up there, etc. Okay? So the number of matches in a complete turn is its order of rotation. This particular one would have an order of 6 because I could turn this shape onto and exactly on top of itself 6 times. So the first example says find the order of rotational symmetry for the star. So they've given you a dot here, and if we started here, and we took this shape and we turned it either clockwise or counterclockwise, 1 turn would get us here, 2, 3, 4, 5. So it's a 5-sided shape. It's not surprising that the order of rotational symmetry for the star is 5. There's not a lot of demonstrating to do in order to demonstrate your knowledge. This one's pretty straightforward and difficult to show any work other than maybe you could go 1, 2, 3, 4, 5. Showing it would be 5 rotations. All right, so pause please, try the check. It's gonna not take you long at all, and then come on back and like to make sure you got it right. All right, so it says find the order of rotational symmetry for each shape using tracing paper. Use tracing paper to help. I don't think that's necessary, but go ahead and do it if you want to, especially if the shape's a little less regular. These are regular shapes because they're very symmetrical, but an irregular shape is hard to tell just by looking at it. So if I had this shape, and let's say I took a dot here, and I started turning it, I could turn it this way, and this dot would end up there. If I kept going, this dot would end up there. Kept going, it would be there, and then it would end up on top of itself. So the shape and its tracing match 4 times. So the shape of rotational symmetry is order 4. This example, very, very similar. So hopefully you're thinking 3, because if I took this shape here and turned it, this one would end up there, it would end up there after 2 turns. 1 more turn would put it exactly where it started. So the shape and its tracing match 3 times, order of symmetry of 3. So obviously this number is related to lines of symmetry, isn't it? How many times are these shapes exactly symmetrical? Absolutely, that's got lots to do with it. Okay, so the smallest angle you need to turn for 2 shapes to match is the angle of rotation, and you calculate the angle of rotational symmetry by taking that order of rotation and dividing 360 by that number. Because remember that if you go the entire way around, you've gone 360 degrees. So example number 2 says find the angle of rotation symmetry for this shape. So we've already talked about this. If you have a hexagon with 6 sides, I can turn 1, 2, 3, 4, 5, and then 6 times. So it's got order of 6. So the angle can be calculated taking 360 because it's 360 degrees the whole way around, divided by 6 turns. So each time I'm turning the shape, I'm going 60 degrees. All right, so your check. talks about this diamond shape. And you really got to think about this diamond shape because remember I told you it's got to do with lines of symmetry and it's got to do with turning. So I'm going to show you this one because it's a little bit different. And what I'm going to do is I'm going to trace. I'm going to make this shape so that I can show you by tracing it onto itself. Okay, so I'm just recreating the shape, and then I'm actually just going to make it a shape by joining all four of those. I'm going to group them into a group, okay? So now, you see how I can trace this on. Now, if I were to turn it about its center, let's see if it will let me do that. I hope it will. Watch what happens. If I turn it once like that, look at how it doesn't sit on top of itself. So you might have been thinking, it can take 4 turns, but if I turn it once, look what happens. That's not sitting on top of itself. I have to turn it all the way to make, let's see if I can get that dot to travel with it. One sec. Dot. Right there. Okay, so that I can keep track, and I want to join that dot with that shape. I'm going to group them. There we go. So if I were to turn it, that dot doesn't match up with that corner, I got to go all the way around so that this shape sits exactly on top of itself. So there's one turn, and then one more turn to get it back to where it was. So the shape and its tracing only match 2 times. I know it's a 4-sided shape, but it does not have rotational symmetry of 4, only 2. So the order of rotation is 2. So I'm going to take that 360 and I'm going to divide by 2 to get 180 degrees. The angle of rotation is 180. I had to go all the way halfway around the circle to get it to match, and then one more time to get it back to the top. So careful about those. Okay, and did you see how tracing worked? It helped out a lot. Okay, so what about this shape? What do you think? If you aren't sure, trace it, and then trace it on top of itself. Looks to me like 3, because it looks fairly regular. 5, 6, and then I'm going to draw that dot just so I've got my starting point. Okay, I'll draw my dot here. I'm going to connect my points. Okay, so if I start turning it, it's going to sit on itself. Let's see. Is it okay to kind of slide it? 1. 1. 2. Well, it doesn't work, does it? It doesn't slide on top of itself at all. I'd have to move it, and that's not how it works. So there I am exactly at the start. And if I turn this, look, I'm never ever sitting exactly on top of myself. Never. All right, so the shape and its tracing match 1 time. That's it. Only when I go the whole way around. The order of rotation is 1. The angle of rotational symmetry, 360 divided by 1, or 360. Okay? And then it says here, shapes that need a complete turn to match again don't really have any rotational symmetry because there's no turns. Okay, so careful. It looks like it should, but not necessarily. Okay, sometimes you can use isometric dot paper to help you rotate, and it says we use isometric dot paper to draw images after rotations that are multiples of 60 degrees. That's because, have a look at this paper. Okay, here's a hexagon, and that's why, because hexagons are 6-sided shapes, and 360 divided by 6, each one 60 degrees. So we can use what we know about isometric dot paper to help us rotate a shape. So what they're trying to show you here is that if you start with this line and you go once, okay, that's 60 degrees. So this is where my new line showed up. Or if you go twice, and that's my new line, you've gone 120. One set of 60, or 2 sets of 60. Okay, so keep that in mind. how many times you need to rotate on isometric dot paper. So this example says rotate parallelogram ABCD 60 degrees clockwise about vertex C. About vertex C means stick your pencil on point C, and that's the point that's staying still. And then draw and label the rotation image. I'm not going to freehand this. I'm going to use straight lines to help me draw this. So all I'm going to do is transfer the shape over here. So I'm going to start at the top. Let's see. 1, 2, 3 dots. Okay, I count it. 1, 2, 3 dots. So when I draw, I go 1, 2, 3. This is going to be 1, 2. Now, this dot paper is kind of different. I'm thinking this dot paper isn't going to be as good, but it'll work. 1, 2. That's the best I can do. And then I'm going to go 1, 2, 3, 1, 2. Okay, so the difference between, why does this shape look so funky? Okay, have a look at the space between the dots. This dot paper, this wasn't the best example of dot paper I could have found, but I'm far into my video and I don't want to start again. So keep in mind, I didn't find the best example of dot paper. Look at how nicely spaced this is versus this one, okay? That's the reason why this is looking so funky. But I'm trying to just copy my shape. So 2, 2, 3 across, 2 up and over. And then I can label my points A, B, C, D. A, B, C, D. Okay, I need to rotate 60 degrees clockwise. Clockwise is this way, like how a clock goes, right? 12, 3, 6, and 9, and clocks go this way. So clockwise and 60 degrees. And I'm keeping still here on point C, okay? So if I went from here straight across and here straight down, that would be, you know what, this is horrible. Horrible dot paper. I'm going to pause and get a better piece. I'm not even going to try to fix this dot paper. I'm going to pause and I'll go get a nicer piece of dot paper and I'll be back. All right, I'm back. That's better. Okay, so I'm going to take my image and I'm going to draw it. I'm going to use straight edges. There we go. Okay, so 1, 2, 3. That's better. 1, 2, 1, 2, 3, and 1, 2. Okay. So my image is A, B, C, D. And I want to go 60 degrees clockwise, about point C. So this is the point that's saying still. Okay, so this line needs to go 60 degrees this way. Okay, count dots. 1, 2, 3. Okay, I'm going to try to use a different color if I can. Hold on. 1, 2, 3. So 1, 2, 3. 1, 2, 3. Okay, this has become this. Okay, this line is 1, 2. So it has to go 1, 2 because this line has gone 60 degrees that way. And then finish up. 1, 2, 3, 1, 2. And that's your new shape, the green one. Okay, so this shape has turned 60 degrees in a clockwise rotation. Okay, so give it a go. Here's the check. I want you to pause. This might take you a while. Some of you are going to find this so easy, and some of you, like me, are going to struggle because your brain struggles to visualize this stuff. Pause, in pencil, give it a try, and then come back and see if you got them right. All right, let's try the check. So we're going 60 degrees counterclockwise. We're going that way about point G. That's the point that's sitting still. Okay, we're going this way. So, oh, we're still on green. Good. So this line 1, 2 needs to go here. 1, 2. This line went 60 degrees. This line 1, 2. It goes this way 60 degrees, so it ends up on top of GH. And then finish up 1, 2, 1, 2. Okay, so hopefully now you can visualize that this shape has gone this way 60 degrees. All right, the last one, 120 degrees clockwise about vertex S. This is the spot that's going to be still. So this line won't end up there because that's 60. This line ends up here. That's 120, twice, 2 turns. So SR ends up here, okay? This line's 2 dots, which is going to end up here. Okay, can you visualize that? And then 2 this way, and finish it up. So I hope you can visualize that it's gone clockwise, 2 turns, sitting still there. Okay, so good luck with your practice. Again, like I just said, some of you will find this so easy and some of you will struggle, and that's okay. Just give it a try anyway.